Hello everyone and welcome back to the next lecture of control systems. In this presentation we are going to have the review of Laplace transform part 5. And in this presentation we are going to have our last property of Laplace transform, which is the convolution property. But before discussing the convolution property, we will have some discussion on the impulse response of an L.T.I system because it will act as a prerequisite when we will discuss the convolution property. So let's get started. Talking about the impulse response of an L.T.I system, firstly we will discuss that what is an L.T.I system. An L.T.I system is the linear time invariant system. L.T.I is the abbreviation for linear time invariant. And that's why we can say an L.T.I system is a combination of both linear and time invariant systems. We will discuss some more points regarding the L.T.I systems in the upcoming sections of this course. Moving on, to explain the impulse response, I will take one block diagram of an L.T.I system. On this side we have the input or the stimulus to the system, and on this side we have the output or the response of this system to this particular input. So we can say that whenever we give the input to the L.T.I system, we will have one response. So if I give impulse as an input to this particular system, then the response I will get is called as the impulse response. So we can say that the impulse response of a system is the response of the system when the input is an impulse signal. So whenever we have impulse as an input to the L.T.I system, the output we will get is called as the impulse response. The impulse response of an L.T.I system is represented as h of t, and the impulse response is a very important parameter of an L.T.I system. We use the impulse response to define the L.T.I system, and that's why we can say that the impulse response is a characteristic of an L.T.I system. And the output of a system to any input is calculated by convolving the input with the impulse response of the system. So we can say that when we have the impulse response of an L.T.I system, we can calculate the output with respect to any input. We just have to convolve the input with the impulse response of an L.T.I system, and hence we will get the output. And that is what we are going to discuss in the convolution property. So now we are done with the discussion of the impulse response of an L.T.I system. We will now move on to the convolution property. So now we are on the discussion of the convolution property of Laplace transform, and it says that if x of t is a function which is having a Laplace transform x of s, and y of t is another function which is having a Laplace transform y of s, then x of t convolution with y of t will have a Laplace transform x of s multiplied with y of s. It says that convolution in time domain is the multiplication in frequency domain. We can understand the significance of convolution property of Laplace transform by using the following example. Suppose if we are having a system, and the system is the L.T.I system of course, and it is having the impulse response as h of t. Suppose if we are having the input x of t given to this particular system, and we have y of t as the output. So we can calculate the y of t, the output of this particular system, in the time domain as y of t is equal to convolution of x of t with h of t. It means that we need to convolve these two functions x of t and h of t in order to calculate the output of the system. And convolution of x of t and h of t is given as y of t is equal to integral from minus infinity to infinity h of tau multiplied with x of t minus tau d tau, where tau is a dummy variable. We can see that the convolution operation is a very complex operation, and it is difficult to find out the output, but if we switch to frequency domain by taking the Laplace transforms of these two functions, so x of t will have the Laplace transform x of s, and h of t, which is the impulse response of the system, will have the Laplace transform h of s. Then by convolution property, y of t can be easily calculated as y of s is equal to x of s multiplied h of s. In this case, y of s is the Laplace transform of y of t. And if we want to find out the time domain function, then we can take the inverse Laplace transform of y of s. And in this way, by the use of convolution property of Laplace transform, we can easily find out the output of any LTI system. So this is the significance of convolution property, and in this way we are done with the discussion of the Laplace transform properties. We have 2 more lectures left in the review of Laplace transform. In the next 2 lectures, we will take some examples based on inverse Laplace transform, and we will see that how we can calculate the time domain function if we are given the frequency domain function. So now we are done with the lecture. I'll end this lecture here. See you in the next one.